Guide to Attribute-Based Access Control, ABAC Definition and Considerations. Executive Summary. The concept of attribute-based access control, ABAC, has existed for many years. It represents a point in the space of logical access control that includes access control lists, role-based access control, and the ABAC method for providing access based on the evaluation of attributes. Traditionally, access control has been based on the identity of a user requesting execution of a capability to perform an operation, for example, read, on an object, for example, a file, either directly, or through predefined attribute types such as roles or groups assigned to that user. Practitioners have noted that this approach to access control is often cumbersome to manage given the need to associate capabilities directly to users or their roles or groups. It has also been noted that the requester qualifiers of identity, groups, and roles are often insufficient in the expression of real-world access control policies. An alternative is to grant or deny user requests based on arbitrary attributes of the user and arbitrary attributes of the object, and environment conditions that may be globally recognized and more relevant to the policies at hand. This approach is often referred to as ABAC. In November 2009, the Federal Chief Information Officers Council, Federal CIO Council, published the Federal Identity, Credential, and Access Management (FICM) Roadmap and Implementation Plan v1.0, FEDSHU1, which provided guidance to federal organizations to evolve their logical access control architectures to include the evaluation of attributes as a way to enable access within and between organizations across the federal enterprise. In December 2011, the FICM Roadmap and Implementation Plan v2.0, FEDSHU2, took the next step of calling out ABAC as a recommended access control model for promoting information sharing between diverse and disparate organizations. In December 2012, the National Strategy for Information Sharing and Safeguarding included a priority objective that the federal government should extend and implement the FICM roadmap across federal networks in all security domains. The U.S. General Services Administration (GSA) and the Federal CIO Council are designated leads for this objective, and are preparing an implementation plan. Despite the clear guidance to implement the FICM roadmap and contextual, risk-adaptive, role or attribute-based access control, to date there has not been a comprehensive effort to formally define or guide the implementation of ABAC within the federal government. This document serves a twofold purpose. First, it aims to provide federal agencies with a definition of ABAC and a description of the functional components of ABAC. Second, it provides planning, design, implementation, and operational considerations for employing ABAC within an enterprise with the goal of improving information sharing while maintaining control of that information. This document should not be interpreted as an analysis of alternatives between ABAC and other access control capabilities, as it focuses on the challenges of implementing ABAC rather than on balancing the cost and effectiveness of other capabilities versus ABAC. ABAC is a logical access control model that is distinguishable because it controls access to objects by evaluating rules against the attributes of entities, subject and object, operations, and the environment relevant to a request. ABAC systems are capable of enforcing both discretionary access control (DAC) and mandatory access control (MAC) concepts. ABAC enables precise access control, which allows for a higher number of discrete inputs into an access control decision, providing a bigger set of possible combinations of those variables to reflect a larger and more definitive set of possible rules to express policies. The access control policies that can be implemented in ABAC are limited only by the computational language and the richness of the available attributes. This flexibility enables the greatest breadth of subjects to access the greatest breadth of objects without specifying individual relationships between each subject and each object. For example, a subject is assigned a set of subject attributes upon employment. For example, Nancy Smith is a nurse practitioner in the cardiology department. An object is assigned its object attributes upon creation, for example, a folder with medical records of heart patients. Objects may receive their attributes either directly from the creator or as a result of automated scanning tools. The administrator or owner of an object creates an access control rule using attributes of subjects and objects to govern the set of allowable capabilities. For example, all nurse practitioners in the cardiology department can view the medical records of heart patients. Under ABAC, access decisions can change between requests by simply changing attribute values, without the need to change the subject/object relationships defining underlying rule sets. This provides a more dynamic access control management capability and limits long-term maintenance requirements of object protections. Further, ABAC enables object owners or administrators to apply access control policy without prior knowledge of the specific subject and for an unlimited number of subjects that might require access. As new subjects join the organization, rules and objects do not need to be modified. as long as the subject is assigned the attributes necessary for access to the required objects. For example, all nurse practitioners in the cardiology department are assigned those attributes. No modifications to existing rules or object attributes are required. This benefit is often referred to as accommodating the external, unanticipated, user and is one of the primary benefits of employing ABAC. When deployed across an enterprise for the purposes of increasing information sharing among diverse organizations, ABAC implementations can become complex, supported by the existence of an attribute management infrastructure, machine enforceable policies, and an array of functions that support access decisions and policy enforcement. In addition to the basic policy, attribute, and access control mechanism requirements, the enterprise must support management functions for enterprise policy development and distribution, enterprise identity and subject attributes, subject attribute sharing, enterprise object attributes, authentication, and access control mechanism deployment and distribution. The development and deployment of these capabilities requires the careful consideration of a number of factors that will influence the design, security, and interoperability of an enterprise ABAC solution. These factors can be summarized around a set of activities. Establish the business case for ABAC implementation. Understand the operational requirements and overall enterprise architecture. Establish or refine business processes to support ABAC. Develop and acquire an interoperable set of capabilities. Operate with efficiency. The remainder of this document provides a more detailed explanation of ABAC concepts and considerations for employment of enterprise ABAC capabilities. This document serves as a first step to help planners, architects, managers, and implementers fulfill the information sharing and protection requirements of the U.S. federal government through the employment of ABAC. 1. Introduction. 1.1 Purpose and Scope. The purpose of this document is to provide federal agencies with a definition of attribute-based access control, ABAC, and provide considerations for using ABAC to improve information sharing while maintaining control of that information. This document describes the functional components of ABAC, as well as a set of issues for employing ABAC within a large enterprise without directly addressing authentication mechanisms or all aspects of identity management. 1. Thus assuming subjects are bound to trusted identities or identity providers. The focus is on core ABAC concepts without addressing in detail topics such as attribute engineering/management, integration with identity management, federation, situational awareness, real-time or contextual, mechanism, policy management, and natural language policy translation to digital policy. The discussed considerations should not be deemed comprehensive. Before selecting and deploying an ABAC product or technology, the hosting organization should augment these considerations with testing and independent product reviews. This document brings together many previously separate bodies of ABAC knowledge in order to bridge gaps between available technology and best practice ABAC implementations, and strives to provide guidelines that can be consistently applied throughout organizations. It can be used as an informational guide for organizations that are considering deploying, planning to deploy, or are currently deploying ABAC systems. This guidance extends the information in NIST 7316, Assessment of Access Control Systems, NIST 7316, NIST 7665, Proceedings of the Privilege Management Workshop, NIST 7665, NIST 7657, A Report on the Privilege, Access, Management Workshop, NIST 7657, and NIST 7874, Guidelines for Access Control System Evaluation Metrics, NIST 7874, which demonstrates the fundamental concepts of policy, models, and properties of access control, AC systems. 1.2 Audience. This document is intended to benefit and address the needs of two specific audiences. Persons who have a basic understanding of access control concepts and desire a general understanding of ABAC concepts. Access control subject matter experts or managers experienced in access control concepts who are seeking detailed deployment or operational information on ABAC. 1.3 Document structure. The rest of this document is divided into the following sections and appendixes. Section 2 provides a basic understanding of ABAC. It gives readers an overview of the current state of logical access control, a working definition of ABAC, and an explanation of core and enterprise-level ABAC concepts. Readers can gain a general understanding of ABAC concepts from just completing Section 2. Section 3 discusses ABAC enterprise employment considerations during the initiation, acquisition/development, implementation/assessment, and operations/maintenance phases. Readers with an interest in access control and/or project management will benefit most from this section. Section 4 concludes the document. Appendix A defines various acronyms and abbreviations related to ABAC. Appendix B lists the references for the document. Because of the constantly changing nature of the IT industry, readers are strongly encouraged to take advantage of other resources, including those referenced in this document. 1.4 Notes on terminology. The terminology is not meant to be mandatory, but is intended to be consistent within the confines of the document itself. Where possible, terminology that is used elsewhere within NIST publications and across the federal government was adopted to maintain consistency. Where terms were found to be used inconsistently or where multiple terms were being used throughout the federal government and the identity and access control community to address a common concept, the most concise terms and definitions were applied. A logical object, sometimes referred to as a resource, is an entity to be protected from unauthorized use. The subject represents the entity requesting to perform an operation upon the object. The subject is sometimes referred to as a requester. The subject is most often assumed to be a human. A non-person entity, NPE, such as an autonomous service or application could also fill the role of the subject. In general, every operation performed by a computer must be done on behalf of some person or organization, in the case of an NPE, with the authority to perform the operation. The term subject is used to denote a human or NPE requesting access to an object. There are characteristics or attributes of a subject such as name, date of birth, home address, training record, and job function that may, either individually or when combined, comprise a unique identity that distinguishes that person from all others. These characteristics are often called subject attributes. The term subject attributes is used consistently throughout this document. In the course of a person's life, he or she may work for different organizations, may act in different roles, and may inherit different privileges tied to those roles. The person may establish different personas for each organization or role and amass different attributes related to each persona. For example, an individual may work for Company A as a gate guard during the week and may work for Company B as a shift manager on the weekend. The subject attributes are different for each persona. Although trained and qualified as a gate guard for Company A, while operating in her Company B persona as a shift manager on the weekend, she does not have the authority to perform as a gate guard for Company B. Authentication is not the same as access control or authorization. Authentication is the act of verifying that the subject has been authorized to use the presented identifier by a trusted identity provider organization. Access control or authorization, on the other hand, is the decision to permit or deny a subject access to system objects, network, data, application, service, etc. Note that ABAC can be used without identification information. An authentication method is not addressed in this document. The terms access control and authorization are used synonymously throughout this document. Privileges represent the authorized behavior of a subject. They are defined by an authority and embodied in policy or rules. For the purposes of this document, the terms privileges and authorizations are used interchangeably in that they are meant to convey one's authority and implicit approval to access one or more objects. Environment conditions are dynamic factors, independent of subject and object, that may be used as attributes at decision time to influence an access decision. Examples of environment conditions include time, location, threat level, and temperature. Policy, rules, and relationships govern allowable behavior within an organization, based on the privileges of subjects and how resources or objects are to be protected under which environment conditions. Throughout this document, the term policy is used to convey these rules and relationships. Policy is typically written from the perspective of the object that needs protecting and the privileges available to subjects. Like subjects, each object has a set of attributes that help describe and identify it. These traits are called object attributes and are sometimes referred to as resource attributes. This document uses the term object attributes consistently throughout. Object attributes are typically bound to their objects through reference, by embedding them within the object, or through some other means of assured association such as cryptographic binding. 2. Information about policy, such as author, policy effective date, deconflict methods, etc. are sometimes called metapolicy. Information about attributes such as attribute authority, attribute creation date, etc. are sometimes called metattributes. Metapolicy and metattributes may be used in the development of sets of policies and the identification of the appropriate attribute sets needed for authorization. A good example of the use of a metattribute is assigning an assurance level or measure of confidence to the attribute, a composite score for an attribute that could combine subjective ratings like a confidence score for the authority behind the attribute, a freshness score of the information in the attribute, and a level of accuracy score for how often the information is validated. At times, these measures of confidence may even be used as input to the access decision. These policies must be enforced through some type of access control mechanism. The access control mechanism must assemble authorization information, which may include information about the object being protected, the subject requesting access, the policies governing access to the resource, and any contextual information needed to make a decision. By evaluating each policy element against the available information, the access control mechanism often employs a policy decision point, PDP, to render a decision, a policy enforcement point, PE, to enforce the decision, and some sort of context handler or workflow coordinator to manage the collection of attributes required for the decision. For the purposes of this document, it is assumed that the term access control mechanism incorporates all of this functionality, and the term is used throughout. Cryptographic binding is a methodology for providing integrity and authenticity to data and data relationships using well-known cryptographic techniques. Cryptographic binding works by determining the hash value of each object attribute associated with a specific object and digitally signing the collection of hash values. When the object is accessed, if the object signature fails, the attribute hash values are then compared to determine which element was modified since the last binding operation. 2. Understanding ABAC. Fully understanding ABAC requires understanding of the basic principles of logical access control. The purpose of logical access control is to protect objects, be they data, services, executable applications, network devices, or some other type of information technology, from unauthorized operations. These operations may include discovering, reading, creating, editing, deleting, and executing objects. These objects are owned by an individual or organization and have some inherent value that motivates those owners to protect them. As owners of the objects, they have the authority to establish a policy that describes what operations may be performed upon those objects, by whom and in what context those subjects may perform those operations. If the subject satisfies the access control policy established by the object owner, then the subject is authorized to perform the desired operation on that object, better known as being granted access to the object. If the subject does not satisfy the policy, then it is denied access to the object. Computer security architects and administrators deploy access control mechanisms, ACM, in logical line to protect their objects by mediating requests from subjects. These ACMs can use a variety of methods to enforce the access control policy that applies to those objects. The ACM can be defined as. How these ACMs function can be described in terms of various logical access control models. These access control models provide a framework and set of boundary conditions upon which the objects, subjects, operations, and rules may be combined to generate and enforce an access control decision. Each model has its own advantages and limitations, but it is important to note the evolution of these models to fully appreciate the flexibility and applicability of the ABAC model. MAC/DAC. An early application of logical access control was applied in Department of Defense, DoD, applications in the 1960s and 1970s with the emergence of the concepts of discretionary access control, DAC, and mandatory access control, MAC. These terms are further defined in the DoD Trusted Computer System Evaluation Criteria, SEC, or Orange Book, SEC. The definition of DAC and MAC can be also found in NIST 853. ABAC/ACLs. As networks grew, the need to limit access to specific protected objects spurred the growth of identity-based access control, IBAC, capabilities. ABAC employs mechanisms such as access control lists, ACLs, to capture the identities of those allowed to access the object. If a subject presents a credential that matches the one held in the ACL, the subject is given access to the object. Individual privileges of the subject to perform operations, read, write, edit, delete, etc., are managed on an individual basis by the object owner. Each object needs its own ACL and set of privileges assigned to each subject. In the ABAC model, the authorization decisions are made prior to any specific access request and result in the subject being added to the ACL. For each subject to be placed on an ACL, the object owner must evaluate identity, object, and context attributes against policy governing the object and decide whether to add the subject to the ACL. This decision is static and a notification process is required for the owner to re-evaluate and perhaps remove a subject from the ACL to represent subject, object, or contextual changes. Failure to remove or revoke access over time leads to users accumulating privileges. ROAC. Role-Based Access Control Model, RBAC, FK92 NC 359, SCFY 96, employs predefined roles that carry a specific set of privileges associated with them and to which subjects are assigned. For example, a subject assigned the role of manager will have access to a different set of objects than someone assigned the role of analyst. In this model, access is implicitly predetermined by the person assigning the roles to each individual and explicitly by the object owner when determining the privilege associated with each role. At the point of an access request, the access control mechanism evaluates the role assigned to the subject requesting access and the set of operations this role is authorized to perform on the object before rendering and enforcing an access decision. Note that a role may be viewed as a subject attribute that is evaluated by the access control mechanism and around which object access policy is generated. As the RBAC specification gained popularity, it made central management of enterprise access control capabilities possible and reduced the need for ACLs. ABAC. ACLs and RBAC are in some ways special cases of ABAC in terms of the attributes used. ACLs work on the attribute of identity. RBAC works on the attribute of role. The key difference with ABAC is the concept of policies that express a complex Boolean rule set that can evaluate many different attributes. While it is possible to achieve ABAC objectives using ACLs or RBAC, demonstrating AC requirements compliance is difficult and costly due to the level of abstraction required between the AC requirements and the ACL or RBAC model. Another problem with ACL or RBAC models is that if the AC requirement is changed, it may be difficult to identify all the places where the ACL or RBAC implementation needs to be updated. One example of an access control framework that is consistent with ABAC is the Extensible Access Control Markup Language XACML. The XACML model employs elements such as rules, policies, rule and policy combining algorithms, attributes, subject, resource, object, action and environment conditions, obligations and advice. Its reference architecture includes functions such as policy decision points, PDPs, policy enforcement points, PEPs, policy administration points, PAPs, and policy information points, PIPs, to control access. Another example is the Next Generation Access Control Standard, ANSI 499. In general, ABAC avoids the need for capabilities, operation/object pairs, to be directly assigned to subject requesters or to their roles or groups before the request is made. Instead, when a subject requests access, the ABAC engine can make an access control decision based on the assigned attributes of the requester, the assigned attributes of the object, environment conditions, and a set of policies that are specified in terms of those attributes and conditions. Under this arrangement, policies can be created and managed without direct reference to potentially numerous users and objects, and users and objects can be provisioned without reference to policy. 2.1 The benefit of ABAC. In many AC systems, logical access control solutions have been based primarily on the identity of a subject requesting execution of an operation, for example, read, upon an object, for example, a file. Examples include IBAC or RBAC where access to an object has been individually granted to a locally identified subject, or when access to an object has been granted to locally defined roles that the subject is a member of. This approach to AC is often cumbersome to manage. In a non-ABAC multi-organizational access method example, authenticated access to objects outside of the subject's originating organization would require the subject's identity to be pre-provisioned in the target organization and pre-populated on an access list. Additionally, the subject qualifiers, such as identity and roles, are often insufficient in the expression of real-world AC needs. RBAC makes a decision based on the subject's association with a role. RBAC does not easily support multi-factor decisions, for example, decisions dependent on physical location, and specialized training such as for Health Insurance Portability and Accountability Act, HIPAA, records access. Recent training on HIPAA data protection may be a prerequisite to view medical records. RBAC role assignments tend to be based upon more static organizational positions, presenting challenges in certain RBAC architectures where dynamic access control decisions are required. Trying to implement these kinds of access control decisions would require the creation of numerous roles that are ad hoc and limited in membership, leading to what is often termed role explosion. A method is needed to make AC decisions without previous knowledge of the object by the subject or knowledge of the subject by the object owner. By relying upon the concepts of subject and object attributes consistently defined between organizations, ABAC avoids the need for explicit authorizations to be directly assigned to individual subjects prior to a request to perform an operation on the object. Moreover, this model enables flexibility in a large enterprise where management of access control lists or roles and groups would be time-consuming and complex. Leveraging consistently defined attributes that span both subjects and objects, authentication and authorization activities can be executed and administered in the same or separate infrastructures, while maintaining appropriate levels of security. 2.2 A working definition of ABAC. ABAC has been described in various ways. For example, one early paper on web services states that ABAC grants accesses to services based on the attributes possessed by the requester, WWJ04, while a discussion of security and geographic information systems describes ABAC as an approach in which attribute values associated with users determine the association of users with privileges, CGL 009. Still another paper summarizes ABAC as a model that is based on subject, object, and environment attributes and supports both mandatory and discretionary access control needs, YT05. In these and other definitions, there is a reasonable consensus that ABAC determines access, i.e., operations upon system objects, by matching the current value of subject attributes, object attributes, and environment conditions with the requirements specified in access control rules. The following is a high-level definition of ABAC. Attribute-based access control, ABAC, an access control method where subject requests to perform operations on objects are granted or denied based on assigned attributes of the subject, assigned attributes of the object, environment conditions, and a set of policies that are specified in terms of those attributes and conditions. Attributes are characteristics of the subject, object, or environment conditions. Attributes contain information given by a name-value pair. A subject is a human user or NPE, such as a device that issues access requests to perform operations on objects. Subjects are assigned one or more attributes. For the purpose of this document, assume that subject and user are synonymous. An object is a system resource for which access is managed by the ABAC system, such as devices, files, records, tables, processes, programs, networks, or domains containing or receiving information. It can be the resource or requested entity, as well as anything upon which an operation may be performed by a subject including data, applications, services, devices, and networks. An operation is the execution of a function at the request of a subject upon an object. Operations include read, write, edit, delete, copy, execute, and modify. Policy is the representation of rules or relationships that makes it possible to determine if a requested access should be allowed, given the values of the attributes of the subject, object, and possibly environment conditions. Environment conditions, operational or situational context in which access requests occur. Environment conditions are detectable environmental characteristics. Environment characteristics are independent of subject or object, and may include the current time, day of the week, location of a user, or the current threat level. The high-level ABAC definition is depicted in Figure 2, where the ABAC ACM receives the subject's access request, then examines the subject's and object's attributes against a specific policy. The ACM then determines what operations the subject may perform upon the object. Basic ABAC scenario explained. 1. Subject requests access to object. 2. Access control mechanism evaluates A. Rules, B. Subject attributes, C. Object attributes, and D. Environment conditions to compute a decision. 3. Subject is given access to object if authorized. 2.3 Basic ABAC concepts. In its most basic form, ABAC relies upon the evaluation of attributes of the subject, attributes of the object, environment conditions, and the formal relationship or access control rule or policy defining the allowable operations for subject-object attribute combinations. All ABAC solutions contain these basic core capabilities to evaluate attributes and enforce rules or relationships between those attributes. See Figure 3 below. Figure 3, Core ABAC Mechanisms. Even within a small isolated system, ABAC relies upon the assignment of attributes to subjects and objects, and the development of policy that contains the access rules. Each object within the system must be assigned specific object attributes that characterize the object. Some attributes pertain to the entire instance of an object, such as the owner. Other attributes may only apply to parts of the object. For example, a document object could be owned by organization A, have a section with intellectual property from organization B, and be part of a program run by organization C. As another example, consider a document residing in a directory within a file management system. This document has a title, an author, a date of creation, and a date of last edit, all object attributes that are determined by the creator, author, or editor of the document. Additional object attributes may be assigned, such as owning organization, intellectual property characteristics, export control classification, or security classification. Each time a new document is created or modified, these object attributes must be captured. These object attributes are often embedded within the document itself, but they may be captured in a separate table, incorporated by reference, or managed by a separate application. Each subject that uses the system must be assigned specific attributes. Consider the example of a user accessing a file management system. The user is established as a subject within the system by an administrator, and characteristics about that user are captured as subject attributes. This subject may have a name, a role, and an organization affiliation. Other subject attributes may include U.S. person status, nationality, and security clearance. These subject attributes are assigned and managed by an authority within the organization that maintains the subject identity information for the file management system. As new users arrive, old users leave, and characteristics of subjects change, these subject attributes may need to be updated. Every object within the system must have at least one policy that defines the access rules for the allowable subjects, operations, and environment conditions to the object. This policy is normally derived from documented or procedural rules that describe the business processes and allowable actions within the organization. For example, in a hospital setting, a rule may state that only authorized medical personnel shall be able to access a patient's medical record. In some system, if the object is a document with a record type attribute of patient medical record, then the medical record rule will be selected and processed so that the subject with a personnel type attribute value of non-medical support staff trying to perform the read operation will be denied access and the operation will be disallowed. Note that this is only one approach to implementing the connection between attributes and rules. The rules that bind subject and object attributes indirectly specify privileges, i.e., which subjects can perform which operations on which objects. Allowable operation rules can be expressed through many forms of computational language, such as a Boolean combination of attributes and conditions that satisfy the authorization for a specific operation, a set of relations associating subject and object attributes and allowable operations. Once object attributes, subject attributes, and policies are established, objects can be protected using ABAC. Access control mechanisms mediate access to the objects by limiting access to allowable operations by allowable subjects. The ACM assembles the policy, subject attributes, and object attributes, then renders and enforces a decision based on the logic provided in the policy. ACMs must be able to manage the process required to make and enforce the decision, including determining what policy to retrieve, which attributes to retrieve in what order, and where to retrieve attributes. The ACM must then perform the computation necessary to render a decision. The policies that can be implemented in an ABAC model are limited only to the degree imposed by the computational language and the richness of the available attributes. This flexibility enables the greatest breadth of subjects to access the greatest breadth of objects without having to specify individual relationships between each subject and each object. For example, a subject is assigned a set of subject attributes upon employment. For example, Nancy Smith is a nurse practitioner in the cardiology department. An object is assigned its object attributes upon creation, for example, a folder with medical records of heart patients. A designated authority creates rules to govern the set of allowable operations. For example, all nurse practitioners in the cardiology department can view the medical records of heart patients. Adding to the flexibility, attributes and their values may then be modified throughout the lifecycle of subjects, objects, and attributes. Provisioning attributes to subjects and objects governed by a rule set that specifies what operations can take place enables an unlimited number of subjects to perform operations on the object, all without prior knowledge of the specific subject by the object owner or rule maker. As new subjects join the organization, rules and objects do not need to be modified. As long as the subject is assigned the attributes necessary for access to the required objects, for example, all nurse practitioners in the cardiology department are assigned those attributes, no modifications to existing rules or object attributes are required. This benefit is often referred to as accommodating the external, unexpected, user and is one of the primary benefits of employing ABAC. Contrary to some other schemes, under the definition of ABAC presented here, operations do not have attributes. As defined attributes contain information given by a name-value pair. For example, read equals all or all equals read is not appropriate. Operations can have many types or classes, which are not attributes but a fixed set of values. It would be possible to make operation itself an attribute name, such as operation equals read, but this would then be the only attribute for operation, which would be redundant. To meet accountability requirements, there will be a need to track accesses of objects to specific subjects linked to specific users. Accountability could be lost if access decisions are based on attributes, but subject or user IDs are not tracked to specific access requests and decisions. 2.4 Enterprise ABAC Concepts. While ABAC is an enabler of information sharing, when deployed across an enterprise, the set of components required to implement ABAC gets more complex. At the enterprise level, the increased scale requires complex and sometimes independently established management capabilities necessary to ensure consistent sharing and use of policies and attributes in the controlled distribution and employment of access control mechanisms throughout the enterprise. The following represents a definition of enterprise for this document. Enterprise, a collaboration or federation among entities for which information sharing is required and managed. Some enterprises have existing capabilities that can be leveraged to implement ABAC. For example, most enterprises have some form of identity and credential management to manage population of subject attributes, such as name, unique identifier, role clearance, etc. Similarly, many enterprises may have some organizational policy or guidelines to establish rules authorizing subjects' access to enterprise objects. However, these rules are usually not written in a machine-enforceable format that can be integrated consistently across all applications. ABAC policies must be made available in machine-enforceable format, and stored in repositories and published for ACM consumption. These digital policies include subject and object attributes required to render access control decisions. The enterprise subject attributes must be created, stored, and shared across organizations within the enterprise through a subject attribute management capability. Likewise, enterprise object attributes must be established and bound to objects through an object attribute management capability. At this point, the ABAC-enabled access control mechanisms must be deployed. The remainder of this section provides more detail on each of these major components of enterprise ABAC. 2.4.1 Enterprise ABAC Policy. Natural language policies, NLPs, are high-level requirements that specify how information access is managed and who, under what circumstances, may access what information. NLPs are expressed in human understandable terms and may not be directly implementable in an ACM. NLPs may be ambiguous and thus hard to derive informally actionable elements, so the enterprise policy may be difficult to encode in machine-enforceable form. While NLPs can be application-specific and thus taken into consideration by the application system, NLPs are just as likely to pertain to subject actions that span multiple applications. For instance, NLPs may pertain to object usage within or across organizational units or may be based on need to know, competence, authority, obligation, or conflict of interest factors. Such policies may span multiple computing platforms and applications. NLPs are defined in this document as follows. Natural Language Policy, NLP, statements governing management and access of enterprise objects. NLPs are human expressions that can be translated to machine-enforceable access control policies. Given that relevant NLPs exist for each organization in an enterprise, the next step is to translate those into a common set of rules that can be enforced equally and consistently within the ACMs across the enterprise. In order to accomplish this, it is necessary to identify all required subject/object attribute combinations and allowable operations. Often these values will vary from organization to organization and may require some form of consensus or mapping to each organization's existing attributes to accommodate enterprise interoperability. The agreed-upon list of subject and object attributes, the allowable operations, and all mappings from existing organization-specific attributes are then translated into machine-enforceable format. NLPs must be codified into digital policy, DP, algorithms or mechanisms. For efficiency of performance and simplicity in specification, an NLP may require decomposition and translation into different DPs that suit the infrastructure of operation units in the enterprise. DPs are defined in this document as Digital Policy DP access control rules that compile directly into machine executable codes or signals. Subject/object attributes, operations, and environment conditions are the fundamental elements of DP, the building blocks of DP rules, which are enforced by an access control mechanism. Multiple DPs may require meta-policies, MPs, or policies dictating the use and management of DPs to handle DP hierarchical authorities, DP deconfliction, and DP storage and updates. MPs are used for managing DPs. Depending on the level of complexities, hierarchical MPs may be required based on the structures for the priority and combination strategies specified by NLP. MP is defined in this document as Meta-policy, MP, a policy about policies, or policy for managing policies, such as assignment of priorities and resolution of conflicts between DPs or other MPs. Once DPs and MPs are developed, they need to be managed, stored, validated, updated, prioritized, deconflicted, shared, retired, and enforced. Each of these operations requires a set of capabilities that will often be distributed across the enterprise and is collectively termed Digital Policy Management, DPM. There may be multiple policy authorities and hierarchies within organizations that have variations on enterprise policy. The rules for how DPs and MPs are managed may be determined by a central authority. Proper DP definition and development are critical to the identification of subject and object attributes that are needed to render an access control decision. Remember that a DP statement is comprised of the subject and object attribute pairings as well as environment conditions needed to satisfy a set of allowable operations. Once the full set of subject and object attributes needed to satisfy the entire set of allowable operations for a given set of enterprise objects is identified, this set of attributes comprises the entire set of attributes needed to be defined, assigned, shared, and evaluated for enterprise ABAC access decisions. For this reason, identifying the NLP and DP must be accomplished by the support of attributes when implementing an enterprise ABAC capability. Additional considerations for management of DP can be found in Section 3 of this document. 2.4.2 Attribute Management in Enterprise ABAC. Next, consider the lists of attributes developed while examining the NLPs and DPs. Without a sufficient set of object and subject attributes, ABAC does not work. Attributes need to be named, defined, given a set of allowable values, assigned a schema, and associated to subjects and objects. Subject attributes need to be established, issued, stored, and managed under an authority. Object attributes must be assigned to the objects. Attributes shared across organizations should be located, retrieved, published, validated, updated, modified, and revoked. Subject attributes are provisioned by attribute authorities, typically authoritative for the type of attribute that is provided and managed through an attribute administration point. Often, there are multiple authorities, each with authority over different attributes. For example, security might be the authority for clearance attributes, while human resources might be the authority for name attributes. Subject attributes that need to be shared to allow subjects from one organization to access objects in another organization must be consistent, comparable, or mapped to allow equivalent policies to be enforced. For example, a member of Organization A with the role Job Lead wants to access information in Organization B, except Organization B uses the term Task Lead to denote the equivalent role. This problem also applies to mapping between an enterprise attribute schema and an application-specific schema, particularly ones built before the enterprise schema is defined and/or commercial off-the-shelf, COTS, products that come with their own built-in schema. Organizations must normalize subject attribute names and values, or maintain a mapping of equivalent terms for all organizations. This should be managed by a central authority. Object attributes need to be established, maintained, and assigned to objects as objects are created or modified. While it may not be necessary to have a common set of object attributes in use across the enterprise, object attributes should be consistently employed to fulfill enterprise policy requirements, and available sets of object attributes should be published for those wishing to mark, tag, or otherwise apply object attributes to their objects. At times, it might be necessary to ensure that object attributes are not tampered with or altered to satisfy an access request. Objects can be cryptographically bound to their object attributes to identify whether objects or their corresponding attributes have been inappropriately modified. Mechanisms must be deployed to ensure that all objects created are assigned the appropriate set of object attributes to satisfy the policy being employed by the ACM. It may be necessary to have an enterprise object attribute manager to coordinate these requirements. In the course of managing attributes, the concept of metattributes or characteristics of attributes arises. Metattributes apply to subjects, objects, and environment conditions as extended attribute information useful for enforcing more detailed policy that incorporates information about the attributes and for managing the volumes of data needed for enterprise attribute management. Metattributes are defined in this document as metattributes, information about attributes necessary to implement MP and DP processing within an ACM. Additional considerations for attribute management can be found in Section 3 of this document. 2.4.3 Access Control Mechanism Distribution in Enterprise ABAC. Finally, consider the distribution and management of ACMs throughout the enterprise. Depending on the needs of the users, size of the enterprise, distribution of the resources, and sensitivity of the objects that need to be accessed or shared, the distribution of ACMs can be critical to the success of an ABAC implementation. The functional components of an ACM may be physically and logically separated and distributed within an enterprise rather than centralized as described in the system-level view of ABAC. Within the ACM are several functional points that are the service node for retrieval and management of the policy, along with some logical components for handling the context or workflow of policy and attribute retrieval and assessment. The main functional points, the policy enforcement point, PEP, the policy decision point, PDP, the Policy Information Point, PIP, and the Policy Administration Point, PAP. When these components are in an environment, they must function together to provide access control decisions and policy enforcement. A PDP performs an evaluation on DPs and MPs in order to produce an access control decision. PDP and PEP are defined in this document as follows. Policy Decision Point, PDP, computes access decisions by evaluating the applicable DPs and MPs. One of the main functions of the PDP is to mediate or deconflict DPs according to MPs. The PEP enforces decisions made by the PDP. Policy Enforcement Point, PEP, enforces policy decisions in response to a request from a subject requesting access to a protected object. The access control decisions are made by the PDP. PDP and PEP functionality can be distributed or centralized, and may be physically and logically separated from each other. For example, an enterprise could establish a centrally controlled enterprise decision service that evaluates attributes in policy, and renders decisions that are then passed to the PEP. This allows for central management and control of subject attributes in policy. Alternatively, local organizations within the enterprise may implement separate PDPs which draw on a centralized DP store. The design and distribution of ACM components requires a management function to ensure coordination of ABAC capabilities. To compute access decisions, the PDP must have information about the attributes. This information is provided by the PIP. The PIP is defined in this document as Policy Information Point, PIP, serves as the retrieval source of attributes, or the data required for policy evaluation to provide the information needed by the PDP to make the decisions. Before these policies can be enforced, they must be thoroughly tested and evaluated to ensure they meet the intended need. This action is carried out by the PAP. The PAP can be defined as Policy Administration Point, PAP, provides a user interface for creating, managing, testing, and debugging DPs and MPs, and storing these policies in the appropriate repository. Finally, as an optional additional component within the ACM, the context handler manages the order of policy and attribute retrieval. This can be important when time-critical or disconnected access control decisions must be made. For example, attributes may be retrieved in advance of an access request, or cached to avoid the delay inherent in retrieval at the time of the access request. The context handler also coordinates with PIPs to add attribute values to the request context, and converts authorization decisions in the canonical form, for example, XACML, to the native response format. The context handler can be defined as Context handler executes the workflow logic that defines the order in which policy and attributes are retrieved and enforced.